Lecture 4, we will see the graphs today. Now in this lesson, we will represent the categorical frequency distributions by using bar charts, pie graphs, Pareto charts, and grouped frequency distributions graphically using histograms, frequency polygons, and ogives. And also we will see time series graphs and stem and leaf plot for frequencies. Now, we will see the graph types for the categorical frequency distribution. If you remember, categorical frequency distribution is used for qualitative variables. And the most common graphs are bar graph, pie chart, and Pareto chart. Here, this picture gives you a good summary of what we will learn about the categorical frequency distribution. Like we use bar graphs and pie chart and Pareto charts. And I want you to draw your attention to here. Look at the values of the variable. These are words, the Facebook, YouTube, and Snapchat. And here we will have maybe the blood types like 0, A, B, maybe. And the Pareto chart, we have also look at the values. These are words actually. So these are all for qualitative data. Bar graph, it's suitable for categorical variable. Length of a bar for each category is equal to the frequency of each distinct value of the category. And the bars can be horizontal or vertical. Okay, let's see this example here, how it is done. Now the average time spent per day on top social media is shown in the table below. So here are the minutes spent, on average on these social media tools, the websites. Use a bar chart to organize data. What can you conclude? Now, first, okay, we can do it this way, the vertical bar chart, or we can do with the horizontal bar chart. Here we write the Facebook, YouTube, and the platform names here, and then we write, we make the bars depending on the height. Here it's 35 for Facebook, YouTube 40, then right here, this is what variable is it, average time. This is what category is it, the category, the platforms, you write their names, the values. And the same thing happens in the horizontal chart, except the bars are horizontal here. So the frequency will be here then, and then the values of the category is given here vertically. Now what we see here in these two pictures, let's look at this one. This is better than the horizontal one. Now YouTube is leading with 40 minutes, and then the Facebook is coming second with 35 minutes, and then Snapchat is the third one, and then it's Instagram follows it, but the least one is Twitter with only 1 minute. So a pie chart, as you understand from its name, a pie chart looks like a pie, and it's a circle divided into different portions or slices, as you see here. And we use the percentages to represent data here. So we say this is, for example, if it is blood type or something else. So we write its name. Let's say this is 0 blood type, and we have the percentage here. This is coming from the data. Now, when you try to draw this picture, the first thing you have to do is to find the angle first. So how the angle, shows how big the slice is. And then after you find it, you draw it with some tool like protractor or something else. But we have to be careful about the angles here. We have different angles. And after finding the angle, so you can write the percentage here and percentages of the categories. So the important thing here is to find the angle and the percentage. So how can you find the angle? You have frequency for each category, and the total here. This is the frequency of the category. Okay, and the total frequency here. And if you okay, let's say the angles degrees. We mean the angle here, the angle, the corresponding angle. So it's f over n, the frequency of the category divided by the total frequency times 360, and the percentage is calculated by frequency divided by the total times the 130, I mean 100%. Or you can also find the angle by using this, like the percent. You find the percent here um, times, the percentage means like something divided by, for example, 50%. We mean 50 divided by 100 times 360, for example. Okay. And, yeah, this is how we do it. How it is done in the questions. Now let's look at this one here. In an election, the candidate A obtained 512 votes. The candidate B obtained 438 votes. The candidate C obtained 232 votes, and the candidate D obtained 85 votes. So the results can be represented here, like in this chart. So A got this many votes, and B got this many votes, and D got this many votes. So it says construct a pie graph. In the pie, yeah, let's see how to calculate the percentages and the angles here. Okay, let me fix this one. It should be angle here. Now they should add up to 360 here, and they should add up to 100. I think it doesn't add up to 360 here because of the rounding here. So we rounded the numbers. Okay, because we use the calculator for it. Okay, let me give you first how to find the percentage here for this one. 512 divided by 12, 1,267 times 100%. So it will give you 40.4%. And you can do the same thing by multiplying this fraction by 360 degrees. And when you round it, so it will be equal to 145 degrees. When drawing it, like these values, you can round them, but it has to be in total 360. Okay, we will draw it. And now if we are doing it by ourselves, first we have to draw a circle and put the angles first, and we have to determine the size of the slices. It's 145 degrees, and this is 124. Let's say this 124, maybe this one, and then 66. Okay, I think this should be a little okay. Let's do it this way. This has to be a little bigger than the 1/3, and this has to be under 24, and then you can do like 66 and 24 here, 66 degrees. Now, after you draw the slices, then you can put the percentages and the name of the categories. Let's say A is 40.4%, and B is 34.5%, and you can do the rest here, C and D. Okay, now let's see. I will show you a precise graph now. Okay, here's what we get at the end. But okay, here you don't see the angles here, but these are the angles we found here. Okay, this is how we do it. The Pareto chart. The Pareto chart um, It's a chart for categorical frequency distribution, and here it's the bar height represents the frequency of an event again, but this time it's almost same as the bar chart, the vertical bar chart, but the important thing here is this one here, that the bars are decreasing in height, okay, decreasing in height. So it means we will make the bar chart this way. It has to go this way. So this is Pareto chart. But this is the difference between the bar chart and the Pareto chart. Okay, let's see the example. Now Khalid is the owner of a restaurant. He decides to make a satisfaction survey of 328 customers. He identifies 8 values criteria on which he asks his customers to give their opinions. And these are the 8 criteria here, 8 evaluation criteria, and on which he asks his customers to give their opinion. In the survey, he asks his customers to put a minus sign on the criterion or the criteria that doesn't give them satisfaction. Now, there are 8 criterions, and the results are like this. They're given in the table. The quality of the services gets the most negative, or gets the most minus. And it seems the customers, they don't like it. And the price comes the second, and the available tables is 98. So it means it's a crowded place, or a small place. Anyway, our goal is to do a Pareto chart. As you see the frequencies here, then they are not descending, not descending. So first you have to do them in descending order. So from highest to lowest, you have to arrange the data by using the frequencies, and then you do the bar chart, vertical bar chart. Now you change. Okay, this 98. The availability of tables was the most one. So when you sort them in a descending order, this comes first because it has 98 minuses, and the frequencies, you put them here, and you sort them. Then the next thing is like you have to put here what availability of tables. You have to put 98 and then make the bar chart 98. Then you can do the rest, by looking at the values here. Okay, here is the precise graph. Now, what can you say about here is okay, as an interpreter. So this is the Pareto chart, and you can say here, yeah, these are the two common, and at least they make a big difference here. There's a big jump, 90, 95 out of 328. This makes a big difference. So these are the two main criteria that don't give client satisfaction. The availability of tables, maybe it's a small place, and the quality of services. And the rest seems to be kind of okay, especially this part here. Okay, that's the Pareto chart. And now let's look at some exercises here. Now, the percentages of white wheat and white bread sold at a supermarket each week is best shown using what type of graph here? The key things are here the percentages. We want to find the percentages, and here there are like only two. If there are only two variables here, I mean not two variables, only three values for a variable or the category, and it's asking the percentage. It's better we do the the pie chart. We will say it's rye, it's something percent, and it's wheat or something percent. It's because of the percentages mainly we use a pie graph. Now, if a data set is showing types of pizza ordered at a particular restaurant indicates 24 out of 72 orders were pepperoni pizza, how many degrees would be needed to represent pepperoni pizza in a pie chart? So in a pie chart, we want to represent pepperoni pizza here. So how do you find the angle here, the degree? So the degree is calculated by the frequency of pepperoni pizza, okay, divided by total frequency times 360. Now this is 24 out of 72 orders times 360. So this has to be, if we calculate, this has to be 100, okay, 120 degrees. When making Pareto charts, data should be arranged. Okay, it has to be, you know, how do you arrange them? You arrange the data in descending order, right? So, okay, let's check the choices. It says smallest to largest, largest to smallest, and increasing time. And clockwise, as you see, this is clearly from largest to smallest. Now, always you have to represent the quantitative frequency distribution, especially the grouped frequency distributions, by using the graphs. So these are the most common graphs we use here. For the grouped frequency distribution, I mean, I can put here the grouped. For the ungrouped distribution, you can use the bar chart and the others for the qualitative data, also for the ungrouped. But here for the grouped, we have mainly histograms, frequency polygons, and Ogilvie's graph. Now, this is a nice summary of what we will learn here, and these are the highlights here. The histograms like the bar charts, but we have the class boundaries used here and the frequency. And for the frequency polygons, we have the class points. We find the class points and we use the frequencies and the heights. And for the Ogilvie's graph, so for Ogilvie's graph, we use the class boundaries versus the cumulative frequency. Okay, we will see all the details here, how to graph them. But these are mostly for the grouped distributions, grouped frequency distributions. For the ungrouped, we can use the previous part for the qualitative frequency distributions. I mean, the graphs for them. Now, we use histogram for grouped frequency distribution, and in a histogram it's a basically bar chart, but the bars are connected to each other, and it has horizontal axis and vertical axis, and the histograms are always vertical. And horizontal axis uses the class boundaries. This is the most important part here. And the vertical axis labeled frequency or relative frequency, and the shape of the data, the center and the spread of data can be found graphically by using the histogram. So for this reason, it's used the most. I mean, the histogram is the most used, most common graph type. Now here are how we do it. I mean, anyway, we will see these steps in the question. The example. Construct a histogram using the frequencies for the frequency distribution of students' heights. Now, we have, assume we have a group frequency distribution for the students' heights, and we have the class limits and the frequencies. Now, the first thing is you have to find the class boundaries. So it says first you have to find the class boundaries. Find the class boundaries. Okay, one. And you found the class boundaries, and you remember how to find them, like subtract 0.5 from the first one and add 0.5 to the second one, and this way. Now, then after this, you write the class boundaries here. So you write the class boundaries here, 49.5, 155.5, and then 61.5, and then for this one frequency 6, so you make a bar of 6, height 6, and then the other one is, sorry, this is 3, so you make a 3 here, and you keep doing this. sorry. And when you make all of them, you'll get it's this one here. Class boundaries. Okay, remember this class boundaries. Put them here. Class boundaries under 9.5, 49.5, 155.5, and the rest. And then for each class boundaries or for each group, write the frequency here. I mean, this is 6, this is 3, then this is 7, and this is 14, and this is 20, you see. Okay, this is what we call, this is histogram. Now the frequency polygon, it's used to display the data using lines that link the frequencies at the midpoint. So these are the important here part is midpoint and the lines here, and of course the frequencies. Now find the midpoint of each class, then write them on the x-axis and place the frequency on the y-axis and draw a line graph corresponding to each point and frequency. Now here the midpoint. These are the midpoints here. The frequency is here. And you find them according to the table. So then you connect them. This is the idea. Okay, let's see how it is done in practice. Now, assume these are given to us. These are, again, the frequency distribution of students' height. And now, if you want to do a frequency polygon using the frequencies, first you have to find the midpoints. The midpoints, you find them first. And remember this, you add these two, the class limits, and then you add them, divide by 2. And you take the average of the limits or the boundaries, and you got the class limits. Now, there is, okay, you put them here, but there's one thing, one important thing here is there's a catch here. 152.5 you write here, and then you write 6 here. Okay, you start with this point, and then it goes to 3, and then it goes to 7, 3, 7, and these are the heights, 14, and then 20. As you see, it's 20 here. Now, okay, now as you see, these points are making the blue line. This here makes the blue part. Now, what about the red part here? So as you see, this is 146.5 and this is 182.5. We don't see them here. We don't see them here. No. So how will we find them? The idea is this. Okay, the idea is this. So so you look at the class limit here. Class limit is 6. Class width, sorry. Class width is 6. And then you will assume the class, the midpoint, we have a beginning midpoint 6 less than the first one. So it has to be 146.5. So 152.5 minus 6. So then we say this is the start. And the frequency of it is 0 because nothing is 146. No data has the midpoint, no group. There's no group with the midpoint 146.5. Then you write here 0. So then you put here this one 0 frequency and this one. You start from here, and when ending it, you add 6 more to this one. This the last one here. You add 6 more, and you got 182.5. And again, the frequency for this one 0 because we made it, and there's nothing here 180 something or yeah with the midpoint. So we put this here and we write the frequency 0. Then we make the red parts. Red parts are coming from these two made up points. we made them up. They were not in the data or in the midpoint, so we made them up. So these are the important things here. So this is the important part here. I mean, if you the red parts. Now, so we formed them. We formed these two. Okay. Now I'll give cumulative frequency distribution. Now this is also a line graph. So we have something like this, and it uses the upper class boundaries, and the upper boundaries are placed on the x-axis and the cumulative frequency placed on the y-axis. So we have some group data, so we put the numbers here, the upper class boundaries here. And then here are the cumulative distribution, your cumulative frequencies, frequencies. So at each time, so it will increase, you know, it will increase because the cumulative frequency is increasing all the time. So we will have this type of graph. So let's look at here. Now let's construct and I'll give a graph using the frequencies for the frequency distribution of heights. Now here is the information again. Now we want to find, okay, the upper class boundaries, this is important, and the cumulative frequencies. These are the two things we will use in graphing or give. Now these are the class boundaries. The upper boundaries are those, see, these are the upper ones. Now these are the frequencies, but the cumulative frequencies are, you know, it will be 6, 0 plus 6, 6 plus 3, 9, 7 plus 9, 16, and then 14, it will be 30, and then it will be 50 now. So in total we have 50 frequencies. So this is how we do it. Like, okay, as a reminder, I can show you these. 0 plus 6, 0 plus, well, each time add these and you will get the cumulative frequencies. And the rest is easy, just you put them in the graph here as 100. You write here 149 and 0. 0 is the height, and 149 is the upper bound. Upper boundary is 155 and 6. Oh, sorry, not this one. This one 6. So 155 point. Okay, show you. It's 155 here, and the 6 is here. So the 6 is the height here. So we got this one. And 150, 161, and then 9. So 9 is here, and 16, it will go like 16, 30, 50, 30, 50, this is the sample size. In 179.5, you obtain 50. So this, connect them with the lines. So it gives you, I'll give graph for the heights. This is basically the graph of cumulative frequency distribution. Now there are two types of graphs. One is, okay, this one is not a graph, but it is something we use to show the frequencies. So we use them for qualitative data. This stem and leaf diagram is developed by 2K in 77, and they're used to display information about the distribution of quantitative data. They perform part of explanatory data analysis anyway. Now we have the number of ultrasound examinations per day in 20 days in a hospital, I guess. So we construct a stem and leaf diagram. In this diagram, these are all, you treat them all 2-digit numbers, and then the first digit will be your stem, and the second digit it will be leaf. For example, you take 2 as 0, 2, and then 57 as 5 and 7. So this will be stem and this will be leaf. And when you look at the numbers here, for example, having the stem 5, so the first digit becomes 5. You have 7 leaves here. Stem and leaf. Leaf means, leaf. What's this? It's a plant, You have this, and you have another leaf. So you have one stem and then the leaf, stem and leaf. I mean, yeah, this is one stem, let's say one branch, and the other one has other leaf. You have leaves, attached to the stem. The idea is this. So this is how we do it. Now, uh, for 0, 2, you write the stem here 0 and 2, 0, 2. So this gives you 0, 2, 0, 2. But here 1, 3, 1, 4. So this is like 13 and 14. They have the same stem, 3, 4. Then we list them this way. For the first stem, for 1, we have 3 and 4. This corresponds to 13 and 14. And for 20, okay, you have 20, 23, 25. So these are the numbers which start with 2. Then you write them as like stem, same 2. The leaves 0, 3, 5. You write 0, 3, 5. In the same way, you can do the rest. So let's look at 3. The numbers starting with 3. 3, okay, 31, 2, 32, 32, 32. That's 2, 3, 4, 3, 6. Okay, now let's look at here. The stem is same, 3, 3, 3, 3, 3. And then you write these here, 1, 2, 2, 2, 2. The data can repeat the values. And 4, I mean, for 44, 3, 45, you have these, and for 51, 52, 57, I think this is easy to see. Okay, this is called the stem leaf plot for the given data. Now we have some remarks. So if you have if the numbers goes like some of them, if you have just like decimal points among the integers, let's say like when you have the 11.5 and you have like 12, it goes like this. So it's better you round them up and you make this 11, 12, 12. So it will be something like 1. So here it says round up the numbers. So you will have 11.5 as 12. So you will have 1, 1, and 2, 2 here. So because 11, 2, and if there are no data values, for example, you have like 10, and then you have 31, 32. And for 2, you don't have. So for 1, you have 0. You have for 2, no number with 2. So you don't write here anything. So then you jump to 3. You don't write nothing. You don't write anything here. So if no data value in a class, write the stem number and leave the leaf row blank here. Nothing. Now, if you are dealing with numbers like the very certain certain numbers, certain type numbers like only fives and 3-digit numbers, but you have only 0 or 5 here, so you can make the stem like this, 0 and 30, 0, you know, depends on the numbers you deal with. You can make big stems or little stems depending on you. I mean, the data. If data is too large, um, I mean, depending on data anyway. So the time series of a time series graph, they used to display data over collected over a period of time, and you want to see the pattern during the sequence of time. So this is kind of very easy. You on the x-axis you put the time, on the y-axis you place the frequency, and then put them here the time here and frequency. Then you use the line segment here. This is another bar graph. Let's see. Let's see this example. Now the table gives the total fuel consumed in power plants in unit 1 million something, we don't know, during 2009 to 2014. This is given. For each year we have this much fuel consumption, and we want to construct a time series graph. We'll write the times here, so 2001, 2002, and it will go up to 2014. And then our heights will be these 32 point, 2, and we will have 33 point something and 35. So then we connect the graphs, we connect the dots, and we'll get the points. As you see, 2001, 32.2. See, we use the squares here, but not important. The squares, they can be different. It can be dots here. So here it goes like this. This is the time series graph for the total consumed fuel consumed in PowerPoint in years between 2001 to 2014. Now let's look at these exercises. A weatherman records the amount of rain that fell in Portland, Oregon each day for a year. So he wants to make a record like day 1, we got this many zero. In day 2, we got, let's say, this many. So this type of graph, what type of graph should he use to show how rainfall changes during the year? Okay, if we have the issue day, each day for a year, we take the record and we do it. This has to be what? It has to be a time series graph, right? Because we have the days here, the time. So it has to be C. Now let's look at here. Okay, blank graph would most appropriately represent the number of students that were enrolled in statistics for each of the past 10 years. Okay, so it means like for each year in the past 10 years. Okay, in the last decade, we can say. Decade means 10 years, decade. And this is how you do it. For example, in 2012, in 2013, you have to write them, right? How many students, how many students, how many students. And what makes this one? This, since there's a each year, it's again a time series graph. Now, let's solve the worksheet problems. What graph should be used to show the relationship between the parts and the whole? So we want to see the whole thing, the whole frequency, I mean the whole population or the whole sample and its parts. Obviously here in time series graph, a Pareto chart, and I'll graph, you have something like this. It's hard to see the parts here in the whole. So the only thing left here is a pie chart, and it's very clear the parts in the whole. So this is A. The answer should be obviously A. Now the researcher wants to construct a pie graph to show the blood types of army soldiers. From 80 soldiers, 25 of them were zero blood type. How many degrees should be used for zero blood type section? So 80 soldiers. The total is 80 soldiers here, and 25 of them is zero blood type. So it's 20 zero blood. So how many degrees it should be? So the question is this. Now, how can you find a degree? The frequency of O, which is 25, the frequency of zero blood type, divided by the total times 360. So now it becomes, when this is calculated, it will be 9 here and 2 here. It has to be, I guess, 100 something. It has to be, if it's like 4.5, and it's a little more than 100. Yeah, it's 112.5. Now the stem and leaf plot shows the scores the student received on a math test. How many students scored at least 92%? Here the leaf, from here you can write the scores here, 62, 66, 67, and we are interested in 92 and above. So here are the grades for 9, starting with 9, 92, 93, 95, 96, no, 97 and 99. Here 92 and more, so at least 92 means like 92 more, like 1, 2, 3, 4, 5, and there's one more 100, so it has to be 1, 2, 3, 4, 5, 6. So 6, it seems 6 students scored 92 and more, or at least 92%, let's say, in the test. So it has to be 6. What is another name for the ogive graph? Ogive graph is making the graph of the cumulative frequency distribution. So this is cumulative frequency distribution. Now the graph below represents the data for the number of airlines in millions for the given year. So we have years here, and for each year we have some value, the number of departures. So it is basically, since we are dealing with the time series, so it will be time series graph. For the following frequency polygon, what is the midpoint for the fifth class limit? So if you remember, the frequency polygon uses the midpoints, and here are the midpoints here, and so here are the midpoints. But in the midpoints, if you remember, so we have some extras here. This is the first extra and this is the second extra. These are not the midpoints indeed. These are not given in the chart. So we add them. So we don't take them as the midpoints of the classes. So we start from the first one, then this makes the first midpoint of the first class, and this is the second one, and the third one, and the fourth one, and the fifth one. So the fifth one will be fifth midpoint will be 53 here. So because this is 38, 42, 41, 44, 47, this has to be 53, which makes B. Now, assume you want to make a stem and leaf plot for the following data: 173, 174, 175, 17, 176, and 181, 182, 192, 94, 95. So what is the stem part for the number 175? Now, this stem part depends on the data, but when we look at the data, clearly we have to make the stem for 17, because 17 and 18 and 19. Otherwise, if you make it for 1, so there will be all of them. So we don't do it for 1, so we have to do it for here 17, 3, 4, 5, and then 6. No, this is for 6, then this is 81 and 82, and here 2, 4, 5. So the step part for 175 is 17. Now the pie chart shows the percentage of types of transportations used by 800 students to come to school. And okay, this is not very clear, so I will write here this is 45%, and it says bicycle. I think this is bicycle, and here this is car with 10%, and bus 38% should be the walking uh, by 14%. Okay, let's check. 45, 30, 50, and this is 30. Okay, this is 30. Sorry, guys, this is 30. Okay, now what is the degree? So this is not very clear here. This is a little blurry. So these are, okay, take these as the pie chart. Okay, these are not written well, but okay, now I wrote them. What is the degree associated with students coming to school by bus? The students coming to school by bus is which part here? So this is asking the degree of the angle here. So degree of angle. So we can say here associated with students coming to school by bus. So we have to find the degree for it. So what's the percentage of bus? Bus percentage is 30%. So you can calculate the degree. It will be 30 over 100. So it's the bus angle will be 130% of 360. If the whole circle is 360, then it will have 108 degrees. So this here, it has to be 108 degrees. Now, how many students come to school by bicycle? Okay, let's look at here the bicycle. So how many total do we have? The total number of students is total is 800 students. And here the pie chart says 45% comes with bicycle. So the number of students, number of bicycle, okay, let's say the bicycle is 45% of the whole. It has to be 45 divided by 100% times 800. So this will give us 360. So it has to be here. We have 360, the answer here. We have 108 degrees in here. Now, what is the name of the above graph? So here, this is cumulative frequency. It's hard to read here, the cumulative frequency. This is cumulative frequency. And this is class boundaries here, class boundaries. And it starts with, okay, let me make it clear here. This is 17.5. And this goes like 22.5. And the other one goes like 27.5. You will add each of them plus 5. So the class width is 5, as you see. Now this is the Ogive graph, because we are using the cumulative frequency here, the Ogiv's graph, or cumulative frequency graph. Sample size, so in the cumulative frequency, the last point you got, the last height is the sample size here, which is 300. This is sample size. So this is 300. The class width, as we see here, the boundaries, the difference between the boundaries 5, as you see. Class width is 5. The class width of the class midpoint of the second class is, okay, this is the second class here, so it will be 22.5 plus 27.5 divided by 2. We find the mid class by this, so this is 25. Now the number of patients with ages less than or equal to 52.5. The number of patients with ages less than or equal to 52.5 is, okay, look at here, this is 52.5 and less, gives you cumulative frequency 250. And the frequency for the fifth class, this is the first class, 1, 2, 3, 4, 5. Frequency of the fifth class is the difference between these two values here, 150 and then 100, so it has to be 150 minus 100, so it has to be 50. So remember that this is frequency, not cumulative frequency. Now let's do this. Give the given, okay, this is given to us the frequency of frequency distribution in the classes, and we want to find the histogram. We want to construct histogram and polygon graph and our Gibbs graph. For the histogram, we need the class boundaries. Okay, remember this, class boundaries, we need them. For the polygon, the frequency polygon, we need the class midpoints. And for this one, we need we need cumulative frequency distribution. The cumulative frequency distribution. Now let's do them. I mean, I will put here the class boundaries. I will tell class boundaries, and then class midpoints. And the cumulative frequencies. Now, what are they? Okay, for 3, I mean the class boundary for this one is for 59.5 and 62.5, and for this one 62.5 and 65.5. So these are all integers, so I'm using 0.5. Okay, this has to be 18.5, 69.5, and 71.5. So sorry, this is 85. Since these are class boundaries, I mean the class boundaries will be same as one upper will be equal to the previous one's lower. Yeah, 71.5. Yeah, anyway, the other way. So 75.5 and 74.5. Okay, these are the class boundaries. The class midpoints, you add them, divide by 2, and 61, and here 64. The midpoints are going with the the class width. So you can add all the time 3 here. And when it comes to cumulative frequency, you can add them like 3 first, and then 20, and then 36, and then 48. With you add 12, and then at the end you got 50. Now we can do the histogram. It will not be a precise graph, but you will understand what's going on here. This is 59.5, and you write here 62.5, and then 65.5, and then 68.5, and then 71.5, and then 74.5. And then what are the frequencies? 3. Let's make 3 here. And then for this one, it will be something like 17 here. And for this one, it will be 16, maybe a little less than this one, a little lower than this one. 16. And then 12, so it will be a little, it will be 12, this one. and for this one it will go up to 2, it will go down to 2, so this has to be 2. This is the histogram. Okay, we're done with the histogram, and let's do the polygon graph, the frequency polygon. The frequency polygon is, so we put the class midpoint 61, 64, 67, and then 70, and then 73. And we have the extras here, the extra, it's 76. You add 3 more because the class width is 3 here, and you subtract 3 less, 58. Here it will be 76 here. So we start from 58 here, and at 58 it's 0, and then 61, this is it will be 3, so it goes to 3 here, and then at 64 it goes 17, and then 67, 16, and then it goes like 12, so 12 will go 12, and then 73, it goes up to 2, and then it will go to 0 when it is 76. So these are the extras we have, okay, for the frequency polygon. You remember them? This is the frequency polygon graph. This is the frequency polygon. Okay, then the last, let's do the last one, the Ogilvy graph. In the Ogilvy graph, we take the upper boundaries, and then we put the cumulative frequencies, and it will give us the graph. So for the, okay, now this time where I'm doing this Ogilvy graph, let's make it blue. And then we look at the class boundaries here, the upper ones. So it's 62.5, and then 65.5, and 68.5, and then 71.5, and 74.5. Okay, and then we look at cumulative frequencies 3, and then 20, and then what else? 20, and then yeah, 36, then 48. Okay, 48. Then a little more, which makes 50. So this is Ogilvy's graph, or cumulative frequency graph. So we are done with 3. Okay, I think that's the end of it. Thank you for watching.